Okay, it's time to switch gears a little and look at a different example. I want to use an inner class to reconstruct a part of Bill's Burger Challenge. If you missed Bill's Burger Challenge, don't worry. You could go back and review it. It's at the end of the Object-Oriented Programming Part 2 section of the course. In that challenge, we created a meal, which consisted of a burger, a drink, and a side. I'll do that, but I'll skip the burger toppings part of that challenge as well as the deluxe meal part. I just want to give you a taste of a different way to implement that code using an inner class. First, I'll create a new class in the dev.lpa.burger package called meal. I want to start with a private inner class called item, and that'll have 3 fields: name, type, and price. All our meal items, burger, drink, and side, will be an item. An item is called an inner class here because it's not static and it's declared as a class member. I want a constructor for this inner class with all 3 fields. And I want to copy that constructor, pasting it directly above. I'll remove the price parameter and the code that's in there and make a call to the other constructor, passing name and type and 0 for price, which it defaults to anyway. Next, I'll override the toString method. I'll replace the generated code with my own formatting and include the 3 fields. That'll print out the type, name and price fields, spaced and formatted. For the meal class, I'll set up some attributes. You can see that burger, drink and side are all using item as their variable type, item being the inner class. For base, you can see I've set a default price of $5. One bonus for nested classes is that both the inner class and the outer class have direct access to the other's instance members. I'll go back to the inner class constructor and I'm going to add some code to make the price be equal to the base price if the item is a burger, otherwise 0. What I want you to notice with this code is that I am assigning the base price, a private field on the enclosing meal class, directly to an attribute on an instance of item if it's a burger. This is an example showing that the inner class has direct access to the outer class's attributes, even private ones. Finally, I'll set up a no-arguments constructor for the enclosing meal class. This constructor constructs a regular meal with a regular burger, a Coke, and a side of fries. I've added a statement to print out the drink's name to demonstrate how the enclosing meal class has direct access to the item's attributes without getters or setters, even though those attributes are private. Both classes benefit from the nested relationship by being able to access all of the other's members, private or otherwise. Moving on, next I want a toString method for the meal class. I'll insert an overridden version after my constructor. I'll remove the call to super.toString and return a formatted string again. So that's a meal, using an inner class item to represent everything in a meal. Let me test this out. Instead of using the main class for testing, I'll create another class in dev.lpa.burger called store. I'll create a meal and print it out. Running this code now, I get Coke printed out, which just confirms that the enclosing class, meal in this case, was able to directly access item's private field name, and I've got an itemized list of my regular meal. That was a very fast demo of how you can use an inner class to build a composition inside of a class when it makes sense to do so. This meal class is very well encapsulated. The meal and items are tightly coupled in this challenge because I've said that Bill sells meals and not individual items. Before I move on, let's look at some issues. Instead of calling the base price base, let's say I want to call it price. I'll change that on the meal class. By doing that, I've got an error in my two-argument constructor because base doesn't exist anymore. What happens if I change that from base to price? Let's find out. Notice as I'm typing I get a pop-up that is showing me meal.this.price. I'm going to ignore that for the moment. Using price here gives me an error, cannot reference item.price before supertype constructor has been called. What's going on here? Well, maybe you've realized that I've got a price field on meal and I've also got a price field on item. If I reference price without any qualifier in the code, it refers to the price applicable to the current scope. In this example, I'm in the item class, so price here in the constructor refers to item's price and not meal's price. How do I tell it to use meal's price and not item's price? Well, IntelliJ gave us that hint when we were replacing base with price. We specify meal.this.price. Now this code runs and compiles as before. I've mentioned several times that JDK16 gave us the ability to have static members on all nested classes. Let's see what this means. I want to add a static method on item that will convert my prices in Australian dollars to US dollars, since Bill's Burger chains are opening up in the US. This method will take any price at any conversion rate and return a converted price. It can be static since the variables needed are all passed as arguments. I'll call this getPrice. If you have your module settings set in IntelliJ to a language level less than Java 17, the use of static here would be an error. If you're getting an error, click File and select Project Structure and ensure Project is selected, and you'll see language level there. Make sure it's JDK 17, which as you can see, it is for me. Getting back to our code, let's add conversion rate as a field on the meal class. I want to add that as a parameter to the noargs constructor, which means this is no longer a noargs constructor. I still want a noargs constructor, so I'll generate one, placing it above this constructor, and I'll chain a call to the other constructor, passing one as the conversion rate, which means there is no conversion, because multiplying any number by 1 returns the same value. I want to call this method first on items toString method. You know by now, hopefully, that you can call a static method without using the class name from within the class itself, which I am doing here. Next, I want to add a method on the meal class called getTotal, which I'll put right above the meal class toString method. Create the total, return the converted price. In this method, notice I'm calling the static method getPrice, but this time I use items class name because this code is outside of the item class. I'll next add that to the toString method below it. I'll add 2 more format specifiers, first separated by a new line from the other items, and pass the text, total due, and then the total price. Getting back to the main method on the store class, I can run the code as before. I get the same prices, but I now see the total price, $8.50. Now I want to create a meal in US dollars and then print that out. In a real application, you would be using an online service to find the current conversion rate at the time of the transaction. But here, I'll just hard code the rate from Australian dollars to US dollars as 0.68. So that means 1 Australian dollar is equivalent to 68 US cents. I will run this code now. You can see the regular meal in the converted price. Although I've only shown you an example of a static method, nested classes can now include a nested interface, a static enum, or a static record, for example, giving your inner classes a lot more functionality. In the next video, I'm going to challenge you to make this meal class a bit more robust with the use of another inner class. I'll see you in that next video.